Hello and welcome back to Cracking the Cryptic. The day after Simon reached some sort of conclusion in The Witness. We're very pleased, well, I'm delighted with that. Hats off to him, and an entertaining watch and play along it was too. Well done to him. Now that was on our live stream yesterday, but you can watch the video now on the channel. Also on Patreon, we published Sam Cappleman-Lynes' 6x6x6 Sudoku challenge. We will put out a video on how to solve that at some point for our $3 Patreons who get, normally they just get videos on the monthly reward puzzle for the $3 rather than $2 per month Patreon subscription. This time they will get a video as to how to solve Sam's 6x6x6 Sudoku. Now there's just 2 days left. 4 p.m. on Monday, our time, will be the deadline on the Looney Tunes Sudoku hunt. So if you have the solution to that and you've been meaning to send it, do so. If you were solving the puzzles and you've just got one left to do, finish it off. If you were thinking of joining Patreon and entering the competition, it is your last chance pretty much. So that is available on Patreon. Now, what else have we got going on? So much. Some intriguing merchandise has been purchased lately. We are very pleased to see that getting sold. One day I hope to meet someone wearing some Cracking the Cryptic merchandise out in public. That will be a very happy day. Now, let's have a look at this puzzle. This is called Pandemonium by Testarossa. And I don't think we've solved anything by Testarossa. It's not the type of car I drive. I think it means redhead in Italian, but I don't think Testarossa comes from Italy. Now, Pandemonium, I think, because there's all kinds of arrows in the grid. So this is a little killer arrow Sudoku, basically. Digits along the arrows sum up to the number in the circle. They could repeat on this one. I can't see any others where they could repeat, but that one they could. This one is just a one circle arrow, so those two cells will be the same. Clues outside the grid, and there's 2 of them. They're both 30. They show the sum of the indicated diagonal. That also can include repeats. And that's all we get. So I think it's Pandemonium, as I say, because there's so many arrows. But they're all quite short. I noticed that as well. The report from testing was, it's fascinating, but it's not easy. And that's the sort of report to fill us with trepidation, or me anyway. So nonetheless, do give it a try on the link under the video. I'm going to start now. Let's get cracking. Get one given digit. That's almost just amusing. There's quite a lot of constructors, I think, who are putting 1 in so it's not none, as if that's a reason. Anyway, what the heck have we got? We've got some areas where there are 2 sets of 2 arrows. So they, I mean, it's useless though. 2 sets of 2, they have to add up to 10. So those cells have to add up to at least 10. Up here, I mean, I don't think there's a significant, okay, column 1 looks good. Right, those 3 arrows have to add up to, sorry, yeah, there's 6 digits on those 3 arrows. So they have to add up to at least 21, the triangular number for 6, by which I mean 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. That's the minimum. But the maximum for the 3 arrow cells, the circle cells, is 24. So there's 3 degrees of freedom within that. Which is not very many. I mean, 9 obviously can't be on an arrow, so it's in one of those cells. But 9's not necessarily in one of those. They could be 6, 7, 8. They can't include a number below 4, but they barely could anyway. I don't know. I mean, this is less use on the opposite column. The little killer clues don't seem to be hitting anything interesting. I mean, they hit that arrow, but 30 is the exact average number for 6 cells because 5 is the average Sudoku number. I'm not at all sure where any constraints are coming from in this. This row has two cell arrows, but sort of, I mean, I don't want to call it a swordfish or anything. It's not. I don't know what we've got here. What can we do to get this puzzle started in any way at all? Well, I mean, the thing to think about when you can't start something and yet it is solvable is maybe set theory. But where? Row 6? I don't know. I mean, there are versions of arrow puzzles that involve a form of set theory. Oh, okay, yes. Maybe. Well, quite likely, because there's nothing else. So those columns, Simon did a puzzle like this before. Those columns have loads of arrows in. These rows only have circles in, no arrows. Now, although the circles can be as low as 3 and the arrows can be as much as 8 and 1, I think there may be something significant about these rows and columns. So, right, let's do some set stuff. Let's purple the columns, green the rows, and then subtract. Okay, what am I talking about? First thing I'm talking about is that every row and column in Sudoku has the numbers 1 to 9. That's part of the rule set. So the set of digits in green have to be exactly the same as the set of digits in purple, because there's 2 sets of those digits 1 to 9. Now, I think it gets, this might be interesting. Right, we can immediately deduct, like we know that purple and green are the same. If I take out these cells, which are coloured purple and green, and therefore are contributing the same amount to each colour, then we're still in the same situation. Green adds up to the same as purple. Now, there are some arrows, 4 of them. Look at that arrow, clearly adds up to the same number as this. So this is not a branch of set theory in which we're keeping exactly the same digits, because obviously if I take those purples out and that green out, I'm removing 2 digits in one case and 1 in the other. But I am removing the same total. So once I've done this for that arrow, that arrow, that arrow, and that arrow, still the greens add up to the same as the purples. And you can see it's beginning to get a little interesting now, because it's only 6 cells in purple that have to be different, but it's 10 in green that for each row have to be different. Sorry, they have to be different for each column in the purple. Right, and well, I'm just going to carry on doing equivalences in the hope that I see something that helps. And I don't want to be too elliptical about this, but those 2 purple cells obviously add up to the same as that one. And they're both on the 30 diagonal. That gets interesting now. So let's colour them out and colour that in purple. Now these 5 cells add up to the same as these 10 cells. Somehow these diagonals are going to come into it. I think, yeah, look at this one. That green cell is the same as those 2. Yes, okay, and that's good, because that is increasing the number of green cells. And I quite like increasing the number of green cells and reducing the number of purple cells. So now I'm thinking I could make those 2 purple instead of that, but that actually increases the number of purple cells, and I'd rather decrease them. Because if I can get the purple cells down to just 1 or 2, the trouble is I may be finished now. what can I do? I've only begun to highlight these diagonals. Maybe we can do a minimum count now. So, or rather a maximum of the greens. Is that the way we should look at it? And a minimum of the purples? No, the purples are 5 cells, so a maximum of the purples. So these could be 9, 8, these could be 9, 8, 7. That adds up to 41. This must add up to 10 at least. Plus 1 and 2, plus 15 along here. That's 28. They're still 13 apart, so there must be something else I can do. Oh, well, maybe I could, yes, I want to use these diagonals in some way. I can switch the green to be those cells. Okay, let's do that. Let's switch that green. Still the greens add up to the same as the purples. I could make this purple just those two instead of that. I don't see how that helps. I'm still absolutely not sure I'm on the right track at all here. Oh, okay. What can I bring this box 8 into it? Maybe I can bring box 2 and box 8 into this somehow. How? How? Those 3 and those 2 add up to 30. What's going on here? Right, I am going to move this purple into those 2 because it's leaving these a bit more alone. Sorry, I suddenly hear some dogs going crazy outside. Don't know those dogs. Don't know what they're doing. But they are a bit off-putting. Now, what can we do with these purple, these white cells? They are 30 minus those 3 green. But do I know what those add up to? Oh, I see. Right, what if I purple this whole box and green this whole box? I'm going to try that. That must be obviously another set of the digits 1 to 9. Yeah, this is getting interesting. I think. Right. Still my greens and purples must add up to the same numbers because I've just added 45 in green and 45 in purple. Now again I can deduct cells that are both purple and green. They're contributing the same amount to each colour. And now look, this is getting more interesting. More interesting because I know that those add up to 30. And if I could deduct them out and these, that would be 30 and 30 deducted from both sums. But what's up with this cell? Have I messed up? I really like this idea now. Look, all I'd be left with in the green is those highlighted, which looks like quite a few cells, but all I'd be left with in the purple, if I could deduct this whole column out, is those 2. But what's up with this? Oh, maybe I make this purple and green. It's contributing to both then. It's got to be the same. So I'm adding that cell to both. I don't know, this is madness. But now I'm going to deduct 30 out of both sums by removing that in the green. And this is why we get these equal little killer clues. Deducting that in the purple. And now look at all these green cells. They add up to the same total as these two. They must do. I'm sure what I've done is right. This is crazy talk. I know Simon once did a puzzle where the top two rows and the bottom two rows had something going on like this. Sorry, the not the top two rows and the bottom two rows. The perimeter rows versus the perimeter columns had circles and arrows going on, but I didn't think I could have solved that. Whereas this must be right. Those two cells, which obviously have a maximum of 17. 1, 2, 3 in the same column could be 1, 2, 3 is 6. These could just be 1, 2, 3 is 12, plus 2 is 14, plus 1 there is 15. But I think this... Oh, let's highlight those two instead of this one. Now, we're still on equal terms. 17 is the maximum there. Let's look in rows. 1, 2, 3, 1, 2, 3. That is 6. And 6 and 6 is 12. And 2 there is 14. And 1 and 2 down here, bingo, 17. The maximum those 9 green cells can add up to is 17. Sorry, the minimum those 9 green cells can add up to is 17. The maximum those 2 purples can add up to is 17. That's where these 2 equivalences must meet, and we are in. That is a 9-8 pair. This is a 1, 2, 3 triple. This is a 1, 2, 3 triple. And this is a 1, 2 pair down here. And this must be right. And okay, it is the break-in, because look, these 2 cells see a 1, 2, 3 triple. They've got to be at least 4 and 5. That's also the maximum, so that's a 9. And there's our first digit in the grid in a most unexpected place that had nothing to do with the break-in. Now these 2 don't have to be 4 and 5. In fact, they can't be. We've got 9 and 8 in this cell. The most this can be is a 7. These have to have at least a 4 in. So that's 5, 6 or 7. Can we, now these, make this add up to 3, 4 or 5? Oh, there's an arrow. That arrow has to be a 4, 5 pair. It's seeing a 1, 2, 3. Perfect. 9 there. This becomes a 3 in the box with a 4, 5 in. That's now a 2, 1. We are away and we are winning. That can't be a 3. That can't be a 3. The 3 in the top row is there. What a break-in. That is bonkers. I mean, I know we've seen a few of these before, but that is mad. Right, in row 6 and column 3, we have some 6, 7s and 8s to place because we've placed all the other things thanks to these 4, 5 arrows. I might have missed another automatic 4, 5 arrow somewhere, but we'll get to it, don't worry. Now, 6, 7 or 8 on this arrow means that has to be 1 or 2. And this has to be, well, look, we've got a 6, 7, 8 triple in the box, so that has to be 9. Now this can't be 6. Now the 9 in column 1, that clearly has to be here. It can't be on an arrow. Still haven't sorted out this 8, 9 that got us in. But never mind. Oh, brilliant. I'm so pleased with myself, actually. You know, you go on a journey and you don't know if it's going to give anything. And then it does. It's fun. Right, 6, 7, 8, 2 in this box has to be here because of that given 2 finally comes into its own. So that's a 7. That's not and that's not. This isn't. And one of these is. That's not useful. This is 6 or 8 in a box which has used 1 and 2. So it can't be 6 because that can't be a 1, 5 or 2, 4 arrow. That's now a 7-6 pair. That can't be 5. This can't be 4-4. Obviously, it can't be 2-6 because of the... Oh, look, we've got a 1 and a 2 used there. It's a 5-3 arrow. Like so. Where does 3 go in the bottom row? I don't know. One of those... Sorry, in column 4, not in the bottom row. 8, 5, 3, 1, 2. So 9... Oh no, 9 could be there and there, so I'm not going to get previous about that. What about this? I've looked at this very briefly. Oh, it can't have both of 1 and 2. That's or 3. So if it's 5, it's 4-1. But if it's 6, it could be 5-1 or 4-2. And if it's 7, there are 2 possibilities. That's not so good. What about this arrow? Can't have a 2 on it. Oh, maybe what about all of these arrows? Yes. Well, hang on. Yeah, let's have a look at these maximums again. So we've got 9 there. These could be 1, 3, 4, and 5. That takes the total up to 22 minimum. 9 plus 2 others there could still be 24. There's still 2 degrees of freedom. That's irritating. Yeah, these probably are 8 and 7. Well, okay, we said that the total of these is 22, 3, or 4. It can't be 23 because 6 can't be used. So it is either 22, 9, 8, 5 or 24, 9, 8, 7. So they are from 5, 7, and 8. 1, 4, and 5 there. I don't think this can be a 1. Because if these were 3, 4, 5, and 6, the next minimum stuff, this would all add up to 27, which is too much. So that's not a 1. There has to be a 1 on the arrows. Now there isn't... okay, the minimums have been affected by this being 4 or 5. So 1, 3, 4, and 6 on those arrows is the minimum. 10, 14, plus those 2 is 23. So these must now add up to 24. So we can forget the 5. That is an 8-7 pair. Now these add up to 24. And I think they then have to be 1, 3, 5, and 6. They clearly can't be an 8. The 8 in column 1 has to be here. 9, 8 would be 17. They're adding up to 24. Yeah, we can't use a 2. That is right. So this becomes a 7. That becomes an 8. This can't be 2, 6, or 7, 1. It's 3, 5. This is going to work. 4 there, 1 or 2 there. That becomes a 4. This becomes 5, 4, 1. Now this must work. 1 and 6, it does work for the 7 arrow. And now we've got the 2s and 1s disambiguated. The sort of leftover X-wing that got us started in the green cells. I'm going to leave the green cells coloured because I'm so proud of having got through that bit. 3 and 5 there. Oh, this puzzle is crazy. Oh, maybe I can use the old little killer clue. 13, 16, not just as a equal thing. Now those 3 add up to 14. It's still a very average sum. So maybe I can't use the little killer clue. Let's just do Sudoku. Oh, look, the purples are resolved by the 8 we placed. 9 and 8 there. So we need an 8 here. Could it be there? I suppose it actually could at the moment. That's weird. Neither of those can be 4 because there's a 1 and a 3 used in both boxes. So they are 5, 6, or 9. Oh, 2 and 2. There's definitely a 2 on this arrow. So it's either 2, 3, 2, 4, or 2, 7. That is 4 or 6 just by Sudoku. Oh, and this arrow contributes to the sum. I don't know how to use this. This is 6, 7, or 8. I'm just going to have a look at this diagonal. That's 1, 6, or 7. Those add up to that. So these add up to 30 because of the equivalence of the arrow in its circle. 9. Let's keep these low. 1 and 6, 10, 16. No, 25. There's 5 degrees of freedom. Actually, that means this can't be a 7. It's very close to meaning this has to be a 1. I don't know. That may not be the... I may come back to that. It may not be the simplest way to go forward at this point, but it might actually prove quite interesting. Now, if there wasn't a 1 on this arrow, it would have to be 3 and 4, making this 7, because that can't be 9 or 8. In fact, 8 is in one of these two cells. Let's do that first. 9 is in one of those two. 2 is in one of those two. Suddenly emphasize that as though it might be significant, although it probably isn't. 9 is in one of those. Oh no, look, by regular Sudoku, 9, 9, 9. That is a 9, and that's on this arrow. So that's yet another 9 arrow. Now, this can't be 9. And in fact, the only 9 in the top row is here. Right, now this sum gets interesting. Those add up to 9. That's 9. That's 18 already. So we've got 12 from these. The minimum they can be is 4, 6, and 1 is 11. So we can only increase one of them by 1, and we can do that. It is 4, 7, and 1, and that diagonal must now work. 9, 18, 25, 29, 30, yes. And that will surely, I think that's going to lead us to a finish, frankly. I mean, it's an astonishing puzzle, but I think it's going to give up on us now. That's either 2, 7 or 1, 8. I don't know which. This is now 5 or 6, so there's no 7 here. What about this? This hasn't really changed. It has changed because it can't be 7. Oh no, my question was, can we avoid putting a 1 on that? And actually, by regular Sudoku, we now can't. So there is a 1 on it. Okay, that's been answered. So this is 3, 4, 5, or 6. Can't be 7 because 6 has been used in this column. So is 2, so that can't be a 3. So that's 1 with 2, 3, not 2, with 3, 4, or 5. So 7, oh look, 7 goes here. Actually, this is much more straightforward than I'm making it. The top row has a 5 and a 6. We can place them. That makes this a 3, 4 pair, a 2, 4 pair. That takes 4 out of here. So that 3 and 5, no, 3 and 1 add up to 4 in that circle, quite a low arrow circle. That's not 7. This is a naked single 3, 5 and 6 to place here. Now, how are we going to make up 5 or 6? 5 could be 1, 4. 6 would put 5 there, so it would have to be 2, 4. And the 4 would have to be here. So that's a 4. This is a 1 or a 2. The 4 has fixed 7 and 4. We've got cells from 5, 6, and 8 up here, but it can't be a 5 or 6 on the arrow because 3 and 4 have been used in the box. So it's 8 with a 1. There is an 8 on an arrow. That always seems kind of deliberate to surprise us. 1 in this column is here, so 2 is here. We've got a 2, 7 pair there. This is part of a 5, 6 pair that we're still to resolve. This is 2, this is 1. This one is solvable, is 7, 6. Oh, I could have filled in that circle ages ago. 7 there. 3 and 1. 3 and 5. 9 and 6. I honestly think we're just finishing off now. So that's a 5, 8 pair. This 5, 4 pair has been resolved, which fixes the 5, 8 pair. That's become a 6 on the circle. 4 and 2 are resolved over here. That resolves the 2 and 7. The 1 and 6 and the 3 and 5 are both definitely resolved. I haven't actually checked the other 30 diagonal, but I'm sure it must be working. I just mistyped something there. Okay, I accidentally overtyped my 2 with a 3. This should finish it. There we go. Let's just check this other diagonal. 4, 13, 16, 17, 24, 30. I mean, that is exactly half an hour. That is 30 minutes for the 30 diagonals. Perfect. That is absolute madness in Sudoku set theory. You basically are forced, and I'm sure that was the path, you are forced to follow all the adding and subtracting of the original top rows and perimeter rows and perimeter columns, and then just to trace it through till you get this weird pattern of colored cells. It's absolute genius in a way. I mean, I guess constructors are just going to find, and I mean the beauty of those 230 diagonals being the same and therefore being addable in. But I mean, I was very pleased to spot that you could just add in these boxes. Oh, just madness. Anyway, great fun. And exactly as the tester said, revelatory but not easy or something. So really interesting stuff. I hope you had a go at that, and I hope you got through it if you did. That's not easy. Well done if you did. Thanks to Testarossa for sending it to us, and thank you for following the channel. As always, we're getting very close to 400,000 subscribers now, and we'll be delighted when we do and put out a video of questions and answers. Thanks very much for watching, and bye for now.